Welcome to The Explainer. Today we're going to pull back the curtain on the real secret that makes 5G work. And spoiler alert, it's not the towers, and it's not even the fancy new spectrum. It's the invisible, super smart engine running the whole show.
So let's just jump right in with a puzzle. A big one. If 5G is supposed to be, up to 20 times faster than 4G, why doesn't it just absolutely obliterate your phone's battery 20 times faster? How is that even possible?
And right there, that question, that gets us to the fundamental paradox of 5G, the thing that makes it so powerful. All that incredible speed and bandwidth was also its biggest Achilles heel.
Okay, so here's the breakdown. Back in the 4G days, your phone's radio was kind of simple. It was always on, listening to the entire 20 megahertz channel, and that was fine, totally manageable. But try to do that with 5G, where the channels can be 100, even 400 megahertz wide? No way. That always-on approach would just be a total disaster for your battery. We're talking dead in minutes. Just not going to work.
So, to fix this power paradox, 5G couldn't just be about brute force. It couldn't just be bigger. It had to be a lot smarter. It needed a completely new, really clever way of slicing up that huge chunk of spectrum.
And that clever solution, it's a concept called the bandwidth part, or BWP for short. This is the magic right here. Instead of making your phone listen to this giant, power-hungry channel all the time, the network says, hey, just listen to this one little slice that's perfectly tailored to what you need right this second.
The best way to picture this is to think of the whole 5G channel as, say, a massive 10-lane superhighway. Now, a BWP lets your phone cruise along on just the quiet service road when it's doing something simple like checking for a new text. It's super efficient, but the moment you want to download a huge file, bam! The network moves you onto all 10 lanes. It's that ability to dynamically resize that saves a ton of energy.
And this flexibility, it is absolutely crucial. I mean, think about it. You've got your high-end smartphone streaming a 4K movie, that's what we call eMBB or enhanced mobile broadband. Then, on the very same network, you have a tiny little IoT sensor that just needs to wake up and send a temperature reading once an hour. Totally different needs, right? Well, BWPs are what allow both of these things to coexist, each getting a slice of the pie that's just the right size.
Okay, so that's the theory. But let's make this real. Let's actually follow your phone through a pretty typical data session and see exactly how these bandwidth parts work in the wild.
We're just going to track 4 really simple steps that you do every day. First, connecting to the network. Then you start streaming a video. You hit pause, and then you hit play again. Simple as that.
All right, step 1, connecting. The second you power up your phone, it doesn't try to bite off more than it can chew. It doesn't go for that whole 10-lane superhighway. Nope. It uses this small, standardized slice called the initial BWP. You can think of it like the on-ramp. It's just big enough to get on the network, wave hello, and do it all super efficiently.
Okay, step 2, streaming. The instant you hit play on that 4K video, the network sees what you're doing and knows you need the big guns. So it immediately tells your phone to switch over to a really wide active BWP. Suddenly, you've got all the lanes of that highway, delivering that buttery smooth, no buffering stream that 5G is famous for.
Now for step 3, pausing. And this is where it gets really, really clever. The moment you hit pause and the data stops, a little timer starts ticking on your phone. When that timer runs out, your phone doesn't wait for instructions. It makes a decision all by itself to switch down to a narrow, power-sipping default BWP. It's basically deciding, okay, time to save some juice.
And finally, step 4, resuming. So you're ready to watch again. You hit play, and the network sends this lightning-fast command. It's called a DCI command, technically, and in less than a millisecond, your phone is right back on that wide active BWP. The switch is so fast, so seamless, you have absolutely no idea it even happened.
So you can see this switching is everything. But how does the network actually manage it all so smoothly? Well, it basically has 3 tools in its kit to get the job done.
It mostly boils down to 2 types of commands. First, you've got something called RRC signaling. Think of this as the slow, powerful setup message. It's what the network uses when you first connect to say, hey, here are all the different bandwidth parts you can use. But for the fast, on-the-fly stuff, that's where the DCI command comes in. That's the super quick signal for all those real-time switches we were just talking about.
But wait, there's a third way, and this one is my favorite because it's so smart. It doesn't even need a command from the network. It's all driven by a simple inactivity timer, usually set to something like, say, 40 milliseconds.
This is that same timer we talked about when you hit pause. The network sets the rules, but the phone enforces them. So if no new data shows up before that timer hits 0, the phone just knows what to do. It doesn't wait around. It just says, well, guess I'm not needed right now, and automatically drops down to its power-saving mode. It's this awesome, autonomous system that's just beautifully efficient.
Okay, let's zoom out a bit and think about the big picture here. What does all this smart switching really mean for the future of wireless? Well, when you add it all up, this whole BWP system delivers 3 huge wins. First, you get the longer battery life we all crave. Second, it means you can connect pretty much any type of device to the network, from a beast of a smartphone to a tiny little sensor. And third, it lets all sorts of different services run at the same time on the same network.
And check this out. This shows just how crazy flexible this system is. For your video stream, the eMBB stuff, the network can set up a BWP with a certain characteristic, let's say 30 kHz subcarrier spacing, which is perfect for pumping lots of data through. But for something like a super-sensitive factory robot, that's URLLC, which stands for ultra-reliable low latency, it can set up a different BWP on the exact same channel with 120 kHz spacing to make it insanely responsive. It's basically creating custom-built virtual networks in real time.
And really, that's the whole point. That's what this all comes down to. Bandwidth parts. They are the hidden engine that finds that perfect balance between 5G's raw, incredible power and the practical, real-world needs of our devices. Like not having a dead battery. It's the intelligence that actually makes all that speed useful. So that leaves us with a final, pretty exciting thought. We've managed to build this amazing layer of intelligence right into the very DNA of our wireless networks. They're not just faster anymore, they're smarter. So the real question is, now that our networks are this smart, what are we going to build with them?